All right, so this lesson is about linear programming, just how to solve a problem, not how to write a problem. So the applications will come soon. This is just solving linear programming and getting the vocabulary down. So take a moment to write this vocabulary, pause if you need to. Optimization is just finding the minimum or the maximum value of something. It's why we have systems of linear equalities, because businesses, business owners, CEOs, they use it to find the optimal circumstance where you would have the most profit or the least cost. So we're going to be using our systems of inequalities to find the minimum and the maximum point. So linear programming, again, is just a type of optimization, and it consists of linear inequalities called constraints. So constraints, they're like the restrictions. They're the box that we must work within. So it's the conditions that need to be met, and we write them as linear inequalities, and again, they're called constraints. An objective quantity is what we want to minimize or maximize. For most of our problems, it will be either maximizing profit or minimizing cost. So for today's assignment, you're not going to have to write the objective quantity and the constraints. I have them written for you. For example, the profit to make X toys at 3 each and Y toys at 2 each. So it's a profit, so it's a P equals, and the X toys at 3 each, so the profit of 3, profit of 2. So that's the objective quantity. So when you have to make, and you have to make some of each but no more than 4. So we can write that X is greater than 0 because we have to make at least some of them. We have to make at least some of the Y, but we can't make 4 total. So these are the constraints. So I have both of these written for you today. In the future, you're going to have to write them yourself. Again, just take a second to write this down. So you're going to graph the constraints. That's just the systems of inequalities like you've done in the past with the shading. You're going to write the objective quantity, but today it's already written for you. Now this is the new part. So you're going to find the vertices, or the corner pieces of the solution. So the ordered pairs that are the extreme outside. So it's where the inequalities cross, but it has to be part of that shaded region. So you're going to find the vertices of the solution, and then you're going to test each ordered pair in the objective quantity to find that maximum and or minimum value, depending on what the question is asking for. I'll show you what I mean. Okay, we're going to start by graphing the constraints. So this first one will be the vertical line going through. So this is an X equals, let me make that neater, an X equals 0. So right like that. And Y equals, so again, we're graphing it as an equation, but then the shading comes in. Now I'm not actually going to do the shading because it's not as pretty here as on your paper, but I know that right now it has to be greater than and greater than, so it will fill this whole first quadrant. Next, I needed to make no more than 4, so X plus Y equals 4. You can graph this in a couple different ways. You can put it into slope-intercept form, so Y is less than or equal to negative X plus 4, or you could use your y-intercept and x-intercept. So if I put 0 in, y has to be less than or equal to 4. If I put 0 in for y, x has to be less than or equal to. So here's 2, 4, 6, 2, 4, 6. So here, and then I'm going to go down 1, down 1, down 1, down 1. So this is my line. So since I knew that all of this was shaded, everything right now that I am showing is part of the solution. But this says it needs to be less than. So it's going to be this part right here. Or I could put in 0. 0 is less than or equal to 0 plus 4. So that's true. So it's going to be this shaded region right here. Okay, so that's my solution of the inequality system, but now we have to test the vertices of the solution. Many times it will not be a triangle, it will be a polygon, but you always find the corner pieces like this. So we have are 3 ordered pairs, 0, 0, 0, 4, and 4, 0. Okay, and then you come back to this objective quantity that is given to you today that you will be writing next week. The profit is 3x plus 2y, and you're going to plug in. So 3 times 0 plus 2 times 0 is 0. 3 times 0 plus 2 times 4 is 8. And 3 times 4 plus 2 times 0 is 12. And because we're looking for the maximum profit, it's going to be this one right here. So we would say the max is $12 at 4, 0. And if it's an application problem, then you would say what it means. So in this case, we started with the toy scenario, so 4 X toys and 0 Y toys. But today, you don't have to do that because it's not an application problem. All right, so last example for today. First, we're going to graph our constraints. So remember these. Here's your y is greater than or equal to 0, and your x is greater than or equal to 0, because again, many times we're working with something that we can't have negative, so it has to be greater than or equal to. So it's all of this right in here. So pretend I'm shading it, but I'm not going to because I don't want to get too messy. All right, next. X plus 2y is less than or equal to 16. So I'm going to put that in slope-intercept form. So 2y is less than or equal to negative x plus 16. So y is less than or equal to negative 1/2 x plus 8. So it will be this line. So I start at 8, and I go down 1 over 2, down 1 over 2, etc., until I reach the other side. Okay, so I kind of jumped ahead because of time. So this one is the blue line, and again we started at 8 and went down 1/2. And here I used the intercepts. So both of the intercepts were 10, so it's this line right here. So again, they're both less than. So if you think of, and again, feel free to, on your notability or on your sheet with colored pencils, it's easier to see, but it's going to be less than here, and it's going to be less than here. So the only place that they overlap is this point right here, this. So next, choose your vertices, and remember it has to be the corner pieces. So there. Now I'm not even going to test 0, 0, because if I'm trying to find profit, I want the best. So I have a 0, 8, I have a 10, 0, and then this one right here is a 5, 1, 2, 3, 4, 5 it looks like. So a 5, 5. So test all your points in your objective quantity. So 5 times 0 plus 4 times 8 is 32. 5 times 10 plus 4 times 0 is 50. And 5 times 5 plus 4 times 5 is 20 plus 25. So 20 plus 25 is 45. So the one that is the most is this, but don't forget to answer. So the max, and again we're going max because of the profit. The max was at 10, 0, and then $50 if we're talking profit. So again, if we had an application problem, you tell me what this meant, 10 of what, 0 of what. But for today, just the ordered pair and the amount.